Good morning, Year 8, and good afternoon, and welcome and hello to today's next special and exciting installment of Maths 101 with yours truly, Mr. Smith. I don't know what that was all about, but anyway, here we go. Good day, guys. How are we? I'm sorry I can't be there today, but I thought I would still try and teach you some stuff so that you are ready for the post-test, which will happen this Thursday. Okay, so I'm going to try and do 3 or 4 topics, have a go, do a bit each night. It's totally down to you. Obviously, the more you learn, the better you'll be in the post-test. So, let's just check what is a factor. We already know that a factor is a number that will divide into a whole number of times. So, example, a factors of 20 would be 1 and 2 and 4 and 5 and... hold on, I'm doing this very different from what I told you. So, let's start that one again. 1 and 20, yep, we know they go together. 2 and 10, 4 and 5, and I think that's pretty much it. So those are my factors, all right? What is a prime number? Well, we know that a prime number has only got 2 factors, of which 1 and itself. So number 5 can only have the factors 1 and 5, and so we say that that is prime. Yay! What is a composite number? A composite number is a number that has 3 or more factors. So if we look at the number 2, does that have 3 or more factors? Nope, it only has the numbers 1 and 2, and so 2 is not composite. Remember, 0 is one of those strange numbers. What is a power? Well, 2 with a floaty 2, that little floaty 2 there is a power. It's an index. It is a floaty number. It is everything that we could want it to possibly be. But that does, in this situation, mean 2 times 2. Remember, the little floaty 2 effectively tells you how many times in which to write it. Right? So if I had 4 with a floaty 2, that would mean 4 times 4. It does not mean 4 times 2. And 4 times 4 is 16. And what we do in numbers, we can also do in letters. So if I have the letter A with a floaty 2, that means I have a square apple, which is a little bizarre, but it's a square apple. Or, more importantly, that is the same as A times A. Okay? And so there's no point putting equals because it's an A squared. Those are the type of things you should have been learning up until today. We know about factor trees, all right? So if I have 26 as a factor tree, I will write that as 2 and 13. Can I go any further? Well, actually, no, not in this case, because 2 is a prime number, as is 13. So I could write 26 as 2 times 13. Let's come and think of something a little bit more complicated. Let's have the number, I don't know, maybe 64. All right, so 64 is 2 and 32. There we go. That's a prime number, so I'll put a circle around it. What about 32? That can be split up into 2 and 16. We're loving it. Oops, done the wrong thing, so we'll ignore that. And that becomes 2 and 8. Put a circle. That becomes 2 and 4. Put a circle. And that becomes 2 and 2. Hurrah! I hear you shout. That is so exciting, Mr. Smith. We are maths geniuses. Okay? So that means 64 can be written exactly as 2 times 2 times 2 times 2 times 2 times 2. Why? Because we've got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And if the question wanted us to write it in index form, what on earth is index form? Well, we know what that means now. Index is just floaty number. So it says floaty number form. Well, we know that that can now be written as 1, 2, 3, 4, 5, 6, 2 to the floaty 6. Wow. Now, the interesting thing is, if that's called index form, what is this called? Well, we call that expanded form. And that is going to be important to you in your pre-test and your post-test, Expanded form tells you just to write things out long ways. So if I go from a squared to that, to a times a, I've gone from index form to expanded form. All right? So remember, expanded form. But why do we use this floaty number business? Well, imagine I had the question saying to find the highest common factor and the lowest common multiple of, let's have, 42 and 70, for example. So 42 and 70. Well, if you remember last lesson, we allowed Joe to stand up there. And he had a really good go at this, and so he remembered that to do this you have to write factor trees. So that's 2 and 21. 2 doesn't go into that, but 3 does, so that will be 3 and 7. So 2 times 21 is 42, yep. And 7, 14, 21, that's good. These are all prime factors, and again there's another word, prime factor. What is a prime factor? Well, prime as in prime number, factor, multiply, or what goes in. So 42 can now be written as 2 times 3 times 7, and we'll now do the same for the number 70. So 70, we'll split that up into 2 and 35. There we go. Well, 2 doesn't go into 35, does 3? No. Does 5? Yep. 5 and 7. All right, so 5 times 7, well, this is turning out to be quite good. So 70 is the same as 2. Now, here's an interesting one, times 7 times 5. And if you notice the way I've lined these up, right, remember that the highest common factor and lowest common multiple has something to do with these columns. So let's think about it. I remember now. Joe got the easy one, a little bit confused, and the hard one he got straight away. So the highest common factor is given by where they are in a column together. So where there are 2 numbers in this column. And because there are 2 that they share and 7 they share, the highest common factor of both of those numbers will be 14. And the lowest common multiple, the one that Joe just missed out on, was you take one number from each column. And so in that case, we've got a 2 and a 3 and a 5 and a 7. So what I'll do now is try and work that out. Well, I can't do that in my head, but what I can do is I can do 2 times 3 is 6, times 5 times 7. So I'm just going to take 2 numbers at a time and multiply them. So 6 times 5 is 30 times 7, and 30 times 7 is 210. So there we go. My lowest common multiple is 210. All right. So factor trees are really important. All right. They can help us find answers. We can do expanded form. We can do floating number form. All right. There's a lot of stuff in each of these questions, and you guys have been doing really, really well at this. Now, what we were working on last lesson was the idea of positive and negative numbers. So let's just recap. Where is there a trick? Well, here's a trick. What is an integer? Well, if you remember rightly, an integer is just a whole number. All right, it's any whole number, and that can include negative numbers. So an integer could be, oh no, -3, or -1, or 7, or 27, or 842. They are all integers. All right, integer. Right, those of you who do computer programming will come back to that later. We also came back with the idea about positive and negative numbers. And we came up with this great idea that a positive and a positive and a negative, if you remember, became a positive. Or if they're the same. Notice 2 pluses or 2 minuses become a plus. And if they're different, a minus and a plus and a plus and a minus, they become a negative. Now, how do we start to use this? Well, it all had something to do with negative numbers. If we were to do 2 plus 3, we would know that was 5. All right, nice and easy example. We've been doing that since childhood. But if I was to have -3 plus 2, well, that's like saying it's a temperature. All right, if you remember your number scale that goes 0, -1, -2, -3, and 1, 2, and 3, and we'll do 4. Then what we're doing is when you add numbers, you're moving up the scale, and when you take numbers away, you're moving down the scale. Now, we're at -3, so the question is effectively saying, well, we're down here at -3, and I'm adding on 2, which means I have to go 1, 2 places up, which puts me at -1. Right? Now, what I was saying to you last lesson was we can actually do this in a slightly different way sometimes. We have to remember that that plus belongs to the 2, and that minus belongs to the 3. Now, we can move them around. So we can actually write that as +2 -3. Well, that plus seems a bit weird there, and so we know that we don't have to write it if it's at the beginning, and that just becomes 2 minus 3, or -1. I think that's a smiley face just to be fabulous. Okay, so positive and negative and adding and taking away numbers is awesome, but don't get confused, as some of you were. We were talking last lesson about, okay then, well, what if I had -2 times 3? Well, this is where these fabulous rules come in. when you multiply negative numbers together, this is my shortcut hint for you, and it works pretty much every single time. We look at the numbers first, so ignore that minus sign and just do 2 times 3. Well, 2 times 3 when I went to school was 6. Having done the multiplication, now we look at the idea of, well, that is a negative, but what is in front of the 3? Well, you could say it's a times, but we know that for all positive numbers, we don't have to write the positive. So a negative and a positive, well, let's look over here. A negative and a positive becomes a negative, and lo and behold. What about 3 times minus 2? Same thing. You do the 3 times the 2 first, which is 6, and there's a little plus here, and a minus there, that becomes a minus. Some of you seem to get a bit confused when we had minus 5 times minus 4, for example. Well, that's okay. It still works. 5 times 4 is 20, and a minus becomes a plus. But actually, we wouldn't normally have to write that plus, so I'm just going to rub it out, and there it's gone. Same works for division, right? If I have 27 divided by minus 3, what do I get? Well, 27 divided by 3, how many 3s are in 27? 9, and I've got a plus there and a minus there, so it must become a minus. Now, having done all of those, I then threw a curveball and I said, well, okay, what happens if I do minus 7 plus 4? And you guys went a bit crazy. It was like, yeah. Well, no, because now we're back to these type of questions. Remember, maths is nothing more than a big, fat trick. And we do not want to be confused or tricked by maths. So let's go back. Minus 7, I'm all the way down here, minus 4, minus 5, minus 6, minus 7, and I'm moving 4 closer to 0. 1, 2, 3, 4, and there we go. So my answer comes out to be minus 3. We do not see the negative and a positive and suddenly go, oh, it's got to be a negative and 7 plus 4 is 11. That would be weird. Then we got to some slightly more complicated questions. So 3 plus minus 4. Well, that sounds stupid. If you say it out loud, 3 plus minus, 3 plus minus, 3 plus minus, plus minus. I don't think so. So what is a positive and a negative? Well, let's just write it out again. A positive and a positive is a positive, and a negative and a negative is a positive, and a positive and a negative is a negative, and a negative and a positive is a positive. So a plus and a minus can be replaced. So what I'm going to do is say, well, okay, that's now going to become they disappear, and I'm just going to write 1 minus. So 3 take away 4 is negative 1. All right? Easy peasy. Love it. So that was the stuff we've been reviewing, but let's just throw one more thing in, because remember, again, maths is a trick. So what if I had 32 divided by minus 16? But hold on a moment, they've put them in brackets. What are these brackets all about? Well, if you remember, brackets say, do me first. But how? There's nothing in the bracket to actually do. You can't add anything, you can't take anything away. So they're there just to try and tell you, well, that minus sign belongs to the 16. So I now have 32 divided by, well, we'll just write the minus 16. We know that 32 divided by 16 is 2. And we have a plus here, we have a minus there, and so it becomes a minus. And that's what we were working on last lesson. Let's try and have a look at some of the new stuff now. Orders of operation. What on earth are orders of operation? Well, that's basically talking about BIDMAS. Right? And if you remember BIDMAS, it means brackets, then indices, or floaty numbers, divide, multiply, add, and subtract. All right? And we have to do things in that order. Otherwise, the chances are we will get a really wrong result. So, let's think. If I have, let's say, minus 3 divided by minus 1 plus 8 times minus 4, for example. Well, let's have a look at this. Now, let's just go and put these in brackets as a bit of a trick. We already know now they don't need them. And let's see what my answer is. So, brackets. Are there any brackets there? Well, there are brackets there, but they don't really mean anything to me. So, I've done brackets. Indices. Are there any floaty numbers? Nope. So, we've done the floaty numbers. Well, the next thing is we have to do the divide. Well, here is a division, so we have to do that bit first. And I'm going to write it over here and go, well, there's minus 3 divided by minus 1. Well, we know how to do that now. 3 divided by 1 is 3, and a minus become a plus. So under here, I'm just going to write that down as plus 3. Now, we haven't done anything with here, so we have to write it down exactly as it is. Don't change anything. We've just turned this bit here into plus 3. So now we look and say, well, is there any multiplying here? Well, there is. There is this plus 8 multiplied by minus 4. Well, I'm going to go that over here. Plus 8 multiplied by minus 4. Well, we know 8 times 4 is 32. And we have a positive and a negative becomes a negative. So there we go. I'm going to have that as minus 32 there. But remember, we didn't use the plus 3. So that's just going to copy down as it is. And I'm not going to put the plus because we know at the front I don't really need it. And so, well, there we go. I've got 3 minus 32. What is 3 minus 32? Well, a little bit of head scratching later. And I get minus 29. So this is all about order of operations, making sure that you do bid maths in the right order. All right? And this thing here about putting the lines underneath or putting the curly brackets underneath and making sure you do those bits first, all right, will save you a lot of time. Now, let's go back for a moment because we know the general idea of footy, all right? And when you have footy, what do we like to do a lot of? Yep, substitution. They are forever substituting people on the pitch and off the pitch, and they change and they run around and then they have a bit of a lie down. All right, not the best footy lover in the world, but anyway. So substitution, what does it mean? It means to take something out and put something in its place. So hold on, let's think of an example. Let's imagine I have 2a. Well, we know, because I've told you, that between a number and a letter is a kissy kissy. So let's write that kissy kissy in. So 2a is exactly the same as 2 times a. But what on earth is this a business all about? Well, in previous years, you may well have done a little bit of algebra and may know that a number can that a letter can stand in place of a number. So this here just stands for a number. We don't know what the number is. They have to tell us. So somewhere we would have to know what the number a is if they want us to do something with it. Well, let's say, for example, the value a is minus 3. Well, the second they tell us what a is, I can now substitute it, which means take out the value of a and put in the place minus 3. So let's see. The 2, well, that's going to stay where it is, but I've now seen an a, and they've told me to let the a be minus 3, and there we go, there is minus 3. Well, that's no trick anymore, because I know what that means. I know that's 2 times 3, which is 6. There's a plus there, there's a minus there, and so if I know that a is minus 3, 2a must be minus 6. And actually, I could change the letter a to mean maybe 10. So what would 2a mean now? Well, that would mean 2 times a, because between a number and a letter is a kissy kissy, and that would be 2 times 10, or 20, all right? So this a is great. It's just standing in the way of something. Well, maths can get a bit more complicated. But remember, what is maths? It's nothing more than a big fat trick. So imagine I have the question, and I say, let a be the value of minus 4, let b be the value of 3, and let c be the value of minus 1. I want you to work out what 2a plus b minus c is going to be. Well, undoubtedly, many of you are now reaching for the telephone to call someone because I am abusing and making your life hard and it's so difficult. But probably not, because remember, if you remember that between a number and a letter is a kissy kissy, then you are halfway to solving this question. So that's the same as 2 kissy kissy a plus b minus c. But we know what the value of a is. So where there is an a, I am now going to do 2 kissy kissy. A is negative 4. I'm going to do a plus, and then there's b, and it says write the value of b, which in this case is 3. I have to write that minus sign. All right, this is where the trick is. There's a minus and there's a minus. And what is the value of c? It is minus 1. Whoa, I've got minuses and pluses and times and everything, but that's okay. You know how to do this because we go back to our ideas of bid maths. Right? So, are there any brackets? No. Are there any floaty numbers? No. Is there any division? No. Is there multiplication? You're damn tootin' there is. So, multiplication. 2 times 4. I'm going to do this line underneath it so I know what I've got to do. Well, 2 times 4 is 8. There is a plus here and a minus there, so that becomes a minus. Have I done anything else with the rest of the sum? Nope. So I'm going to write all of that, plus 3 minus 1 down, and start again. So I've done all my multiplication. Is there any addition? Well, of course there's addition. Here we go. Ooh, no. That's a bit tricky. Well, I've got a minus and a minus together. I shouldn't really have had that. So I'm going to change that now, because I know that a minus and a minus can be replaced with a plus when they're side by side. So I have minus 8 plus 3 plus 1. Well, there is addition, but I can do that now like it's an ordinary sum. Why? Because minus 8 plus 3, well, let's do that bit first. That's going to give me minus 5. And then I'm going to write down the plus 1. And then minus 5 plus 1 is minus 4. Yay! This stuff's awesome. People think that algebra is difficult. It isn't. If you remember that a letter can stand in place of a number, it's brilliant. Well, what about floaty numbers? What about if we try the same thing? Well, let's stick with the same numbers and make it really tough. A is 4, B is 3, C is minus 1. Let's do something like, I don't know, A squared plus B squared. We've got floaty numbers now. Well, remember, let's do a bit of side learning. Remember that A squared is the same as A times A. So let's write that out that way. We're going to write that as A times A plus B times B. Well, do I know what the value of A is? Yep, they've told me. So it's minus 4 times minus 4 plus 3 times 3. And that looks horrible, but it's okay because we've got bid maths. So B-I-D-M-A-S. Is there any brackets? No. Are there any indices? No, because I've just got rid of them. Division? No. Multiplication? Absolutely, there's 2 lots. So let's do it. What do we have here? Well, there's a multiplication. Minus 4 times minus 4. Well, we know that 4 times 4 is 16, and a minus becomes a plus. I'm going to put it in there for the moment. And hold on, we've got another times here. We've got plus 3 times 3. Well, we've got 3 times 3, which is 9, and a positive is also a positive. So we've done our multiplication. Is there any addition? Well, that's all that's left. Now remember, that plus in front of the 16, I don't really need to write it anymore. Why? Well, because it's just an ordinary sum. It's just 16 plus 9, which, when I went to school, and some would argue I've never left, is 25. All right? Nothing here is complicated. You can do all of this stuff. I'm going to do one more thing, or maybe 1 or 2 more things. Well, if we have A squared is the same as A times A, I wonder what the opposite of the squared is. Well, let's think. 10 squared is the same as 10 times 10, which is 100. 8 squared is the same as 8 times 8, which is 64. 4 squared is 4 times 4, which is 16. And if you remember, these numbers should start to look familiar, because something else I've told you to revise is this list of numbers here. 144, 121, 100, 81, 64, 49, 36, 25, 16, 9, 4, and 1. And in fact, for those who are stiflingly intelligent, you may also remember 169, 196, and 225. Yep. If you've remembered what these numbers are, they are in fact called the square numbers. All right? Why are they called square numbers? Because they are numbers that, when multiplied by itself, give you these numbers. All right? So, if I was to say to you, how do I work out the opposite of a square? That's given by something called a square root. Now, it's interesting that it starts with the word square. So it actually gives me a hint in maths as to what I'm going to do. But this root thing, other than being somewhat bizarre in Australia, means something like this. Well, let's do an example. If I have the 25 and I want to find out what number, when multiplied by itself, will give me 25, this is what I do. I use this sign here. It's called a square root sign, and that means exactly that. Which number, when multiplied by itself, will give me 25, and the answer in this case would be 5. Oh, love it. Let's do another example. Here's 49. I want to find the square root of 49. So that means what number, when multiplied by itself, will give me 49? Well, I know that 7 times 7 is 49, so it must be 7. Woo! Come on, it's got to be harder than this. Yeah, let's just do another one. And the square root of 169. Well, because we know that 13 times 13 is 169, we would write 13. Okay, really, really hard one. I want the square root of 27. Hold on a moment. Does anyone see 27 in that list? Nope, there's a 25, there's a 36. Does that mean I can do this in my head? Nope, sorry, can't be done in your head. So it just turns out that your calculators have a square root button, that when you actually do 27 and the square root button, it will give you a whole load of numbers, normally to lots of decimal places, and that will be your answer. Okay, so these numbers here are awesome because they are just fabulous. What about if I had a different number? What about if I had, I don't know, 8 with this little sign again, but a 3 here? Well, the great thing about maths is it's relatively sensible. So what that means is, well, really, I should put a 2 here, and a 2 here, and a 2 here, and a 2 here, because that's really how we should write a square root sign. But in the way that we don't write pluses in front of numbers, we tend not to write the little 2. We just tell people that that's what it means. But what that 2 stands for is there are 2 numbers that multiply together give me 27. So I wonder what this 3 here means. Well done. It means what number, when multiplied by itself 3 times, gives me 8. Wow, that's hard. So what it's saying is a number multiplied by a number multiplied by a number, and these are the same number, by the way, give you 8. Well, it's got to be a pretty small number, all right, because otherwise it's just going to get crazy. So what's 1 times 1 times 1? That can't be it. That's 1. All right, let's try 2 times 2 times 2. Well, 2 times 2 I know is 4. 4 times 2 is 8. There you go. My question mark must be 2. So we know that the cube root of 8 is 2. Or otherwise, 2 times 2 times 2 is 8. Oh, one more thing, and then I'm going to let you just fly. Okay, last thing then. We're going to talk about something called indices. And you're going to go, yeah, but hold on, you've already told me what an indice is. It's a floating number. Well done, congratulations. And I think last lesson we were talking about floating numbers. If you remember rightly, we decided that a times a was equal to a squared. And we said that a times a times a must be a with a floaty 3, because there are 3 of them. And a times a times a times a is equal to a4, and a times a times a times a times a must be a with a floaty 5. So the question is, what is a squared times a cubed? Because I can obviously do that. Well, if I write it out long ways, I know that a squared is the same as a times a. And I know that I've got a times sign in the middle, and that a cubed is a times a times a. And I've noticed I've got 1, 2, 3, 4, 5 a's, so that must be a to the floaty 5. Woo! What about a squared times a squared? Well, if I write that out in expanded notation or expanded form, there we go. I've got a times a and a times a with the a in the middle, but we know that's the same as a with a floaty 4. And for the more observant amongst you, you'll notice there's a bit of a pattern. What do you notice about 2, 3, and 5? 2, 2, and 4. Well, if you are still listening, and I hope you are, then what you've noticed is hopefully if I do 2 plus 3, I get 5. And if I get 2 plus 2, I get 5. No, I don't. I get 4. Oh, here's an interesting idea. So if I have b cubed times b to the 4, so long as these bottom letters are the same and there's a times in between them, I know that the answer must have something to do with adding these two numbers together. And that's true. That becomes b to the floaty 7. Ooh, what about b to the 10 times b to the 5? Well, are the bottom letters the same? They sure are. So I can do this, and I can just do 10 plus 5 is 15. This power stuff is great. What about b squared times b cubed times b to the 4? Well, does that work? Well, of course it does. This is just index form. We could write it out in longhand if we want, and we'd have b times 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 b. But we now know that if all of these letters here are the same, then I can just add the powers, so long as they are multiplied. So 4, 5, 6, 7, 8, 9, there we go. So if I've got a to the 4 times b to the 3, can I do this? Are these bottom bits the same? No, so it can't be done. It would just stay as a to the 4 times b to the 3. Maths is a big fat trick. And these are the type of things here that they will try and do to confuse you. So how do you stop yourself from being confused? You just learn the rules. Last few questions, right? Let's just see where we go. If I have 2a times 3a, what is the answer to that? Well, again, this is where life becomes interesting. Do we have floaty numbers? Nope, we don't have any floaty numbers, so that's no good to me. Oh, hold on. I know that between the 2 and the a is a kissy kissy. So I'm going to do 2 kissy kissy a kissy kissy. And there's my 3a. I've got 3 kissy kissy a. Brilliant. Love it. How does that help me? When everything is multiplied, when all the things are multiplied together, what can we do? We can move things around. We can move stuff. All right? Well, why? Well, let's look at the numbers. What's 1 times 2 times 3? All right, 1 times 2 is 2. That's 6. Well, what's 3 times 2 times 1? Oh, that's also 6. And what's 1 times 3 times 2? 6. And what's 2 times 1 times 3? 6. What do you notice about all of these numbers? They're exactly the same. They are just in a different order, but with minuses, with times between. And so I can do the same thing here. I'm going to put all my numbers together, and I'm going to put all my letters together. So I'll get 2 times 3 times a times a. I've just moved them around. Well, I know what 2 times 3 is. That's 6. And hold on a moment. I know what a times a is. That's a squared. So I have got 6 times a squared, which, if I want to make it simpler, I would just have 6a squared. Now, just be careful. If I had had 2a times 3a plus 4, I would not have been able to do it, because now not all of the terms are connected by kissy kissies. So that wouldn't be able to be done the same way as I'd done earlier. Guys, I think that's pretty much it for me at this moment in time. So, what work am I looking for you to do this lesson and for the revision? Well, the work I've just done a moment ago was based on stuff from chapter 1.8, all right? So, I want you to have a look at the Year 8 textbook, exercise 1.8, right? And the questions will be given to you by your extras teacher, okay? So they'll be given to you at the start of the lesson. Some of you may already have listened to this on YouTube on Monday night. Some of you may well have just left it and not bothered. Okay, well, okay, so that's your choice, but now you've got a lot of work to do. And once you finish that, I want you to have a look at the Year 8 textbook again, but this time exercise 5.10. And again, the questions will be given to you by your extras teacher, right? I hope you've enjoyed this so far. The great thing about the video is you can stop it and go back and pause it and watch me work out stuff again. And I wish I could do all of my lessons like this for you, but sadly, I don't have the time. But maybe one day we can record them properly. All right? So here's a smiley face from me. Have an awesome lesson. Please be good for the extras teacher. As far as I'm concerned, they are me, and you are expected to behave for them as you would for me. And you sit in silence for me and you work, and I would expect the same from that. All right? Have a good lesson. Your homework is to finish the work that I put on the board. I'll see you next lesson.